Example number 2. Let's say we have sine square x cosine 5x dx.
Sine squared x cosine 5th x dx. Okay. Now we have an even and an odd exponent, so our case is different.
So which one is odd?
Oh, I was just saying sine squared x is even, cosine to the 5th is odd.
Yeah, so this one is odd. So if cosine is odd, then we will substitute sine.
Right.
I hope you have understood the reason why we are doing. I want to make sure that you know why we are doing something. So you should not blindly do it like, oh, cosine is
No,
odd.
I understand. Like the
Yeah.
rules. I get it.
Yeah, so the reason we are now substituting sine, because now when we will differentiate it in the denominator, we will get a cosine, and that cosine will cancel one cosine of this. So cosine will also become even. Okay?
Right. So we're saying in this case, since that we have an odd cosine,
Yeah.
I think we can do it either way. Like we started with cosine, so now we're substituting u as sine. But if we started with sine squared x, then we would have to substitute u equals cosine x. Right?
No. In this case, always remember that we want to see even powers. If we have odd powers, we will try to make it even. Now here we have this odd.
Oh.
We have this odd power. This odd power will always give us trouble.
So we want our exponents to always be even.
Yes, and that's why I'm taking sine of x as u, because now when I will differentiate this, this will become cosine of x dx equals du. So dx becomes du over cosine of x. And now when I will put this value here in place of dx, so one cosine of x will get cancelled with one cosine of x. So this will also become even, like it will become cosine 4.
Oh, that makes so much sense. I see what you're saying. Okay, so then it'd just be sine squared x times cosine to the 4x dx.
du.
Du, sorry, not dx, du.
Yeah, let's do it step by step. This is sine square x. Cosine, actually sine is now u. This is u square times cosine 5x, and dx is du over cosine of x. So see, now one cosine of x will get cancelled and this will become 4. So this makes the power even.
Right.
So u square
times cosine to the 4th x du.
Now we can easily convert cosine 4 in terms of sine.
Right.
So this is 1 minus sine squared.
Sine squared x.
Yes, and this is whole squared du.
And we already have u as sine, so can't we just say u squared 1 minus u squared squared?
Exactly.
And we can distribute it. Well, actually, no, never mind. Well, I mean,
yeah, first we need to,
in the parentheses.
So 1 minus u square whole square will be 1 square, that is 1, plus u square whole square minus 2 times u square.
And then we can distribute u squared.
Yeah, now I'm going to do this. I will write u to the power 4. Now we can distribute everything. So this becomes u square plus u to the power 6 minus 2 times u to the power 4. And I'm going to distribute the integral as well. So du, du, and du.
And then you just have to make sure that at the very end, now that you have what you have, you can technically start plugging in. You would get like 1/3 u cubed plus 1/7 u seventh minus 2/5 u fifth plus c. Sub back in u with sine x.
Exactly. 2u5 over 5, and then let's put u equals sine x back. So this becomes sine cube x over 3 plus sine 7x over 7 minus 2/5 sine to the power 5 plus c. This plus c will come in this step.
Got it. And that is what I got.
Perfect. Okay. Let me put this inside a box. Okay.